Here are some examples of solving two-step equations. The first one is solve the equation 5b plus 3 equals 18. So thinking of SADMEG, we look for subtraction and addition first to undo. Here we have adding 3, so we need to subtract 3 from both sides, which will eliminate the 3 and give us 5b equals 15. We now have division and multiplication. We have multiplying by 5. 5 times b equals 15. So we need to undo multiplying by 5 by dividing both sides by 5, which leaves us with b equals 3. The variable is now alone on the left, so we are finished, and our equation becomes b equals 3 for our solution. A second example is w divided by 2 plus 6 equals 10. Solve the equation. So SADMEG tells us to look for addition and subtraction first. So here we have adding 6. So first we undo it by subtracting 6 from both sides, which cancels out the 6 to leave us with w over 2 equals 4. We now have that equation, so dividing by 2, we're going to multiply by 2, which leaves us with w equals 8. The variable is alone and on the left, so that is our final answer, and the solution, w equals 8, solves the equation. The next example, 3j minus 4 equals 14. So here we have subtracting 4, so SADMEG tells us to undo the subtracting 4 first by adding 4 to both sides, which cancels out and leaves us with negative 3j, which it should just be positive 3j, but let's see if we're going to divide. Yeah, this should be positive 3j, because it was a positive multiplying by positive 3 when we started. So here we're going to divide by positive 3. Since it's multiply by positive 3, we're going to divide by positive 3 to give us a positive 6. So j equals 6. The variable j is by itself. It's alone and on the left. So our solution is j equals 6. Solve the equation. Here's another example. Negative 2x plus 3. So here we are first SADMEG, we're adding 3, so we're going to undo that first by subtracting 3 from both sides, leaving us with just negative 2x equals negative 4. We then have multiplication of negative 2, so we're going to undo it by dividing by negative 2 on both sides, which will undo the multiplying by negative 2 and leave us with x equals positive 2. The variable is alone on the left, so we are finished, and that's our solution, x equals 2. Another example, negative 2m minus 4 equals 22. Solve the equation. So here we have subtracting 4, SADMEG. Subtraction gets undone first by adding 4 to both sides, which cancels out from the left, leaving us with negative 2m equals 26. We then have multiplying by negative 2, so we'll divide both sides by negative 2, which will leave us with just m equals negative 13. The variable is alone and on the left, so we are now finished. That's the solution to our problem, m equals negative 13. This equation, this example, m divided by 3 minus 5 equals 0. We want to treat the same way with SADMEG, so we're going to undo the minus 5, the subtraction, first by adding 5 to both sides, which will cancel that out and leave us with m divided by 3 equals 5. That's this part here. And we're multiplying by 3 because we divided by 3. Multiplying would be the inverse. So that would give us m equals 15. Leaving the variable alone and on the left, so that's where we stop and we finish with our answer. Let's solve this equation for t. So here we have 5 equals 15 divided by t, and that means that when we're done we'll have t alone and on the left side of the equation. So think about the examples we just saw and what you would need to do using SAD/MEG and operations on both sides of the equation to get that variable alone and on the left side.